Hi, I'm Jake Audette, and I'm going to be taking the test today, and I'm going to be doing the first problem. So starting with here, part A. Just checking, yes, I'm recording. Okay, starting with part A. We're given an electron, the Tesla, direction, velocity. Find the magnitude of the magnetic force on the electron. Well, first, I'm going to draw our graph and seeing for what it gives us. It says we're on the X and Y plane. Therefore, there's going to be a Z. And I'm pretty bad at drawing 3D, so I'm going to go, here's our origin. I'm going to go Y this way, X this way, and then Z is going to be up here. Or actually, I'm going to make that a little lower. Y, Z, X. And it says we're on an X and Y, Z plane. And we have our magnetic field magnitude. I'm going to write that as B. I'm going to do dotted lines for magnetic field magnitude. B. And we have our velocity. And that's going to go right here. And it's on the X and Y plane. I know it's on the X and Y plane. It's just I'm drawing it 3D, so it might look a little weird, but it was always hard drawing 3D ones. But yeah. And we are asked to find the magnitude. Okay. So for that, we're going to use the magnetic force law, which is force equals positive charge velocity times the magnetic field times sine. We also have our angle right here. All right, and plugging that in, we have 1.6 times 10 to the negative 19 times 2.20 times 10 to the 5 times 1.65. That's our magnetic field, and then sine of 60 degrees. I'm going to throw all that in the calculator now. That gives us 2.90 times 10 to the negative 14 newtons. Okay. So that is our answer for the first one. And going on to part B, it asks us to find the direction of the magnetic force on the electron. Well, we see that it tells us it's on the X and Y plane. Therefore, it's going to be on the Z plane, and I'm going to draw that. Well, and okay, it says it's on the Z plane. We know that it's on the Z plane, but our charge is a negative charge. It's a negative charge. Therefore, instead of going this way towards the Z, I'm going to draw it going out the other way because it reverses if it is negative. So our direction would be z, but because the charge is going to be a negative z, so our direction is negative z. And our force is going the opposite way. Yeah, okay. Going on to C now. There's a charge particle moving presence. Find the magnitude of the charge on the particle. Okay, we basically have the same problem, but this time different values, and we're finding the charge instead. So I'm going to draw the graph first again, and it tells us we are okay. Okay, so this one isn't asking for the direction. So we're going on the y and x plane again, pretty sure. Yeah. If I'm not mistaken. Okay, this time. I'm gonna draw it a little bit easier this time because it doesn't ask for direction, so there's no point drawing the no point drawing the z. So we have our magnetic field and our velocity, and our magnetic field equals, was it 0.750 t? Okay, and it also, okay, here's our velocity, which also equals 0.95 times 10 to the what? Fifth? Yeah, 5 meters per second. And it is 36 degrees. I almost forgot. I'm gonna write the values in for this too. I didn't write them in. I wrote them over here when I did the calculations, but just to make it nice and simple, I'll write them in now. And that is 2.20 times 10 to the 5th ms meters per second. And our degrees, I didn't write it in. Just writing it in now. Almost forgot. 60 degrees. Okay. So moving back to our problem. Okay, we have velocity, the magnetic field, magnitude, and I wrote down the angle. Okay, and it's asking for the charge. Okay, so instead of writing our formula up here, the magnetic force law formula, we're just going to change it up a bit. We're going to do the charge equals the force above our velocity times our magnetic field and sine. And plugging that in. And also, okay, yeah, no, I'm just going to write the force, but we're not going to know until after. And then force is going to be 2.5 times 10 to the negative 10 over velocity, which is 1.95 times 10 to the 5 times our magnetic field and sine of, what was it, 36 degrees? Yeah. It's like hiding from me. 1 second. which gives us 2.91 times 10 to the negative 15 coulombs. Okay. And alright, we have a positive charge around the x and y, so our force is probably going to go this way. Because it's plus x over here. Remember, plus x. Because it is still 3D, I guess. Okay. Moving on to D, though. Doesn't ask us for a direction. But, yeah. D. Particle charge. I'm just going to write that a little bit higher. Save space. Particle velocity. Find the magnitude of the magnetic field. Okay. It's just time we're finding B. Well, drawing our thing first. With only a z component. Okay. In the y direction. So from that, we're going to be on the It'll be on the x and z plane, so yeah, okay. So just x and z plane. So I'm gonna write z up here and x on our right. And our y, which will be negative y, will be over here. So when we have our magnetic field, and it says it equals a z component, so I'm gonna write that as bz right now. And our velocity is over here, which equals also on a z component 3.75 times 10 to the 5th meters per second. And well, because we're on an x and z plane, if it was the direction, the force is going to point in on the negative y plane. Yeah, because we have a charge, so it's going to point down here. Force 1 newtons. And then we were asked to find the magnetic field. So again, all we do is just change up the formula again. We're going to do B equals, if we change it up, it's going to be, well, hold on, our angle. I almost forgot to put our angle. Our angle is 90. Yeah, it looks like we don't have, so it's just 90 degrees because we don't have one. So let's do a little thing. Sine of 90 is just 1, so our sine goes away. So that's why I was confused. I'm like, our sine goes away. So instead of writing out the full thing, it's just going to be the force over the charge times velocity, which is equal to, our force was given, where's it at? 2.10 times 10 to the negative 15 over, we have a positive charge, 19, and our velocity, which is 3.75 times 10 to the 5th. And we'll put that in the calculator. This gives us 1 point, I'm going to round it up a little, 1.75 times 10 to the negative 2. Or not round up, but I'm going to move it up to make it look nice. Celsius. Okay. Knowing that, it asks us for E to find the direction of B, but up here it said that the presence of a magnetic field with only a Z component, therefore, I mean, it tells us right there that it's in the plus Z direction. It's going up right here, so it already tells us it's in the Z direction. And it's going to stay that same because our charge is positive, so it doesn't flip either. So isn't that neat? Going to F. Find the ionized atoms, the magnetic field is in the plus Z. The magnetic field is in the plus Z direction. Find the magnetic field is in the Z plane. Find the magnetic field. Okay. This one looks a lot more difficult. XZ plane. Okay, but we have. Okay, I'm gonna do our Z up here. X over here, and our magnetic field right here. But the velocity again, it's asking for the magnetic field. Okay, we're not giving it. Okay. Velocity, I hate drawing 3Ds. Make this X. And our velocity is going to go over here. And we have an angle of 36.9 and from the Z plus X axis and 53 from the plus Z axis. Okay. Well, we don't know what our force is yet, but oh wait, no. It's a positive. It's on the X and Z plane, so it's gonna go this way. But we have an angle here and an angle here. We have 36 and 0.9, and we have 53.1. And our velocity is right here. Okay. And it's asking us again for the magnetic field, which this time our angle is not so easy. Force over charge times velocity sine. And we have our force, which is 2.3 times 10 to the negative 15 over our charge, 2.08 times 10 to the negative 18. Velocity, 7.30 times 10 to the 3 meters per second. And sine. 36.9. And that in our calculator. gives us our magnetic field equals, sorry. I guess I was gonna write it again in the thing, but the answer didn't, so I'll just write it as 0.189 Teslas. Yeah, okay. So yeah, once again, we used the magnetic force law, and we just moved it around for the magnetic field to equal that. So that's what we're looking for. Okay, and now it asks us to find the direction on the ion. And since we're on the X and the Z plane, it's going to go in the one that's not there, which is the Y plane. But in this case, it's going to be in the negative Y plane. That's just how it works, I think. Yeah. So G, negative Y direction. Because it's only on the X and Z plane, so it's naturally going to be on the negative Y plane. And the charge is positive, so it doesn't change. Okay. Okay. Well, thank you for watching.